All right, cool. First, we have David presenting epigenetic therapy in the treatment of solid tumors. David, take it away.
Cancer is one of the deadliest diseases in the world. It's claimed the lives of almost 10 million people just last year. It's traditionally treated using methods like chemotherapy or radiotherapy, but these treatments often cause unwanted side effects due to their lack of specificity. In recent years, epigenetic therapy has risen as a promising alternative. Epigenetics involves changes in gene expressions that don't alter the DNA sequence, but can significantly affect cellular behavior. These changes occur through mechanisms like DNA methylation, histone modifications, and non-coding RNAs. In cancer, such epigenetic alterations can lead to the silencing of tumor suppressor genes or the activation of oncogenes, contributing to tumor progression. Epigenetic therapy, on the other hand, aims to do the opposite. Instead of merely attacking these cancer cells, like traditional treatments do, it focuses on reversing the abnormal epigenetic changes in order to restore normal gene function. By reactivating silenced tumor suppressor genes or inhibiting the expression of oncogenes, epigenetic therapy targets the root cause of tumor growth at a molecular level. This approach not only helps in controlling cancer progression more precisely, but it also reduces the harmful effects that are typically associated with chemotherapy and radiotherapy. As a result, epigenetic therapies are emerging as a more targeted and more personalized approach for cancer treatment, offering hope for a more effective and less invasive option for patients. My research for my literature review was conducted focusing on three primary epigenetic mechanisms: DNA methylation, histone modifications, and non-coding RNAs. I examined how abnormal changes in these areas would contribute to cancer progression and the potential for targeted therapies to reverse these changes. I also explored factors affecting the efficacy of these therapies, such as the tumor microenvironment and genetic mutations, and also investigated the potential of combining epigenetic therapies with immune checkpoint inhibitors. On the first image on the left is a model of DNA structure. There are two sections of chromatin: heterochromatin, which is closed, and euchromatin, which is open. Heterochromatin is inaccessible for transcription, leading to gene silencing, while euchromatin is the opposite, leading to active gene expression. DNA methylation is also shown, which, as the name suggests, is the addition of methyl groups, which are typically added to DNA with the intention of silencing genes, along with histone modifications like acetylation, which impact the interaction between DNA and histones, thereby influencing the chromatin structure and gene expression. Various inhibitors are also shown, like BET, HDAC, and DNMTIs, which inhibit various proteins and enzymes in the DNA in order to give it a more relaxed structure and make it more accessible to gene activation. And on the second diagram is a sort of repeat of the first, but with a closer look at the particular molecules involved. In section A, we have DNA methylation being shown, where a methyl group is being added to a cytosine residue. In section B, we have a close-up diagram of histone modifications, including acetylation, methylation, phosphorylation, and ubiquitination. And in section C, D, and E, we have what are called non-coding RNAs, which are another means of epigenetic modifications. They're crucial in the regulation of gene expression and play a key role in cancer progression. By targeting these non-coding RNAs with synthetic miRNAs, intagomeres, siRNAs, or long non-coding RNA-based therapies, these non-coding RNAs serve as a true prospect in the realm of cancer treatment. The results of my research demonstrated that drugs such as DNMTIs and HDAC inhibitors have shown promise in reversing abnormal epigenetic changes and restoring normal gene function. Clinical trials have demonstrated the efficacy of these drugs in treating various types of solid tumors, and additionally, the combination of epigenetic therapies with immune checkpoint inhibitors have shown improved outcomes, suggesting an almost synergistic effect. I also found that factors like the tumor microenvironment and genetic mutations play a significant role in therapy efficacy, highlighting the importance of personalized approaches in cancer treatment. In conclusion, this review underscores the potential of epigenetic therapy in the treatment of solid tumors. These therapies offer a targeted approach aiming to reverse abnormal gene regulation without actually altering the DNA sequence. Clinical trials have shown promising results, and combination therapies have demonstrated improved outcomes. However, further research is needed to refine these therapies and integrate them into standard care. The future of cancer treatment lies in these personalized approaches by utilizing biomarkers and tailored therapies to improve patient outcomes. Epigenetic therapies represent a promising avenue, offering hope for more effective and less harmful cancer treatments. Lastly, I would like to thank the Harvard Undergraduate Open Bio Student Research Institute for the opportunity and my mentor Theodore Reed for providing text resources and revisions. And I'd like to thank you all for listening.
Perfect. Thank you, David. All right, we're going to move on to Emily Yoon, who's going to present pan-tissue mapping of transcription factor activity. Scores reveals robust markers across cell types and tissues. Emily, take it away.
You hear me okay? Good afternoon, everyone. My name is Emily Yoon, and today I'm excited to share my project titled Pan-Tissue Mapping of Transcription Factor Activity Scores Reveals Robust Markers Across Cell Types and Tissues. Now, you must be thinking, what the heck is she yapping about? Well, to provide a brief background, transcription factors are proteins that control gene expression by regulating specific genes through the binding of DNA regions. Disruptions in the transcription factor regulation can lead to diseases such as cancer. Various studies have attempted to gain more insights regarding transcription factor regulation. However, most of these have relied on bulk RNA sequencing methods. Such sequencing methods aggregate data across many cells and cell types, which can obscure the unique transcriptional states of individual cells. To combat this issue, single-cell RNA sequencing can provide gene expression information at an individual cell level with high resolution, which can help understand transcription factor roles in different cell types through measuring transcription factor activity. Transcription factor activity refers to the actions of transcription factors in controlling target genes, and target genes are the specific genes these transcription factors influence. In our study, we aim to further understand the transcription factor regulation in normal data across diverse tissue types. For that, we utilized the Tabula sapiens, which is the single-cell RNA sequencing dataset. This dataset comprises of 93,000 cells, spanning 18 tissues and 104 epithelial cell types. We have used this data to answer specific questions, including which transcription factors that are common to different cell types and tissues. Furthermore, we seek to develop transcription factor-based cell type marker discovery resources. In terms of our methods, as you can see on the extreme right, we use Tabula sapiens data and perform default single-cell pre-processing and annotations. After this crucial step, we use Dorothea, which is a method developed to infer transcription factor activity from single-cell data. After Dorothea ran, the transcription factor activity scores were collected across all of the 18 tissues, and we were able to formulate potential answers to these 4 questions in this figure. The transcription factor activity per tissue, the top transcription factors across different cell types, the correlations between transcription factors, and the correlations between different cell types. For additional validations to be employed, we created 2 case studies. For the first case study, we applied a classification model based on a machine learning method, random forest, on an independent single-cell lung data from Travaglini et al. For the second case study, we investigated transcription factor dysregulation by comparing cancer single-cell lung data to the normal single-cell lung data from Bistroff et al. Now that I've shown you the workflow of our entire study, I would like to explain our findings. In the top left figure, the average transcription factor activity per tissue inferred using Dorothea, and the top 2 transcription factors from each tissue are displayed. As shown, some of these transcription factors are common to each other, such as TED, JUN, and MXI1. This result motivated us to understand whether there are common transcription factors across multiple cell types. So we discovered this list of 35 transcription factors, which is depicted on the bottom left side. Importantly, some of these are also considered essential genes like MYC. We also wanted to understand their internal correlation. We found the Spearman correlation of transcription factors, and we can observe that transcription factors belong to the same families, such as KLF and SP1. They are also correlated in their transcription factor activity scores, which is shown right next to the previous figure. Next, we wanted to determine the applicability of our transcription factors in other single-cell data sets and in different conditions. For this, we employed Travaglini et al.'s normal lung single-cell data set to accurately map the right cell types and using our identified transcription factors. The area under the curve value of 0.74 was achieved when predicting the correct cell types in the unfamiliar normal single-cell lung data set, which indicates that our list of transcription factors can be used as a transcription factor-based cell type marker resource. Next, we seek to further investigate the diagnostic ability of transcription factors, where we did a full change between cancer tumor and normal lung data. We were able to identify that transcription factors like RFX2 and AR are down in tumors compared to normal. Yet the values were insignificant, which were expected as we used single-cell data and the p-values may have been inflated. Taken together, this computational method sparks novelty for identifying cell type-specific transcription factor markers that are applicable to various data sets. This resource containing our list of transcription factors and their activities across 18 tissues and 104 epithelial cell types has been deposited into GitHub, which is linked and is publicly available for the research community. I must note that all of this research could not have been conducted without the guidance of my mentor, Manuel Gondal, who I'm deeply inspired by. I also like to thank the Open Bio SRI staff for always answering my inquiries and providing tips during office hours. Lastly, I would like to thank the rest of the mentees who I got to engage with more and made this program more enjoyable. Thank you for listening.
Amazing. Thank you so much. And with that, we'll move on. And so we have Fatima presenting psychological and neurobiological impacts of caregiving for children with cognitive disabilities, a study on stress, cortisol levels, and resilience. Whenever you're ready.
Hi everyone, my name is Fatima and I'm going to be presenting my project. So my research examines the psychological and neurobiological effects of caregiving, particularly mother of children with autism and ADHD. I hypothesized significant changes such as evaluated cortisol levels and increased stress. My study involves hypothetical surveys, cortisol measurements, and sleep tracking. The collected results suggest that caregivers exhibit heightened cortisol levels and stress. The study highlights that the need for better support and interventions for caregivers, emphasizing the unique bond influenced by microcortisms. Microcortisms are cells that remain in the mothers after giving birth and pregnancy to a child, and I related this to having a deeper and emotional connection and to the child. So there's more stress experienced by the caregivers. Thus, understanding these impacts is crucial for improving the quality of care. So caregiving for children with cognitive disabilities, both physically and psychologically demanding. Caregivers often experience burnout with symptoms including fatigue, anxiety, and depression. Chronic stress affects both mental and physical health, leading to worsening overall well-being. Cortisol, a hormone released by adrenaline glands in response to stress, impact various bodily functions. Elevated cortisol can lead to a range of health issues, including impaired immune function and increased risk of chronic disease. Recognizing these stressors and their effect is vital in developing targeted interventions to support caregivers' well-being. So my method of what I did is I created a control group and I created sorry guys, I created control group and a different group where,
Sorry.
No, it's okay. Yeah, so I investigated the neurobiological and psychological impacts of caregivers of children with cognitive disabilities, specifically focusing on stress and cortisol levels. Our participants included 13 mothers of children with cognitive disabilities, which was our actual experimental group, and then 15 mothers. It was the comparison group. So, sorry, the control group. We studied anxiety levels, sleep quality, and self-care, and then the cortisol levels were measured and sleep was tracked using a phone app or a survey. So our results. So our results indicated that caregivers of children with cognitive disability experience higher levels of anxiety and elevated cortisol levels, especially in the morning and night. This suggests that these caregivers face significant psychological and neurobiological challenges. Additionally, caregivers in the comparison group reported better sleep quality, further highlighting the increased stress feared by caregivers of children with cognitive disabilities. So for our first one, for psychological impact, we can see that the controlled group has a lower score for the anxiety score, and it's 39. So that was what we hypothesized. And then for the the comparison group, they had a score of 27. So, and then in the next one, the neurobiological findings, we just basically measured the cortisol levels, and you can see that throughout the day. In the morning, the comparison group has a higher cortisol level compared to the control group, and then throughout the day, it's evening out. And then at the end of the day, the comparison group still has a higher amount of cortisol levels compared to the control group. And then after that, the last one is the resilience and coping strategies. So on average, how we did this was we calculated sleep per night. So what they had to do was they had to track how much they slept, like how many hours they got on average per sleep per night for a whole month. And basically caregivers in this group, for the comparison group, got about 5 hours and 33 minutes per night compared to caregivers and the control group who got 6 hours and 6 hours and 55 minutes per night. So the average that we said that adults should usually get is 7 hours. So it's significantly less for the comparison group. And as you can see, I have another graph, and that one is the blue dots represent the comparison group where there's a notably like different trend with higher anxiety scores associated with higher cortisol levels, suggesting that increased anxiety among these caregivers correlate with elevated psychological stress. And the green dots represent the control group. And in conclusion, like caregiving for children with cognitive disability leads to significant psychological and neurobiological effects. The elevated stress and cortisol levels highlight the need for targeted interventions to support caregivers, addressing the unique need for these caregivers and essential for providing their quality of life, and so they can provide a better quality of caregiving for their children. And our findings emphasize the importance of recognizing the key and important role of caregiving, especially for children with cognitive disability. And I'd like to acknowledge the Student Research Institute program for this amazing opportunity. And I'd also like to thank my mentor, Bobby Khan, for her invaluable guidance and her always helping me with finding articles. Thank you.
Awesome. Thanks so much. Next up, we have Favor presenting investigating light-enhanced nanoparticles for topical applications. Whenever you're ready.
Hey everyone, thanks for joining us today. My name is Favor Digibe and I'm a rising senior at Georgia High School. My mentor is Hezekiah Williams from the University of Notre Dame. This summer, we explored nanoparticles as a treatment for various skin disorders. So today I will be presenting on light-enhanced nanoparticles, or MPs. First off, let's talk about what nanoparticles are. Nanoparticles are materials ranging from 100 nanometers to 300 nanometers in size that can be modified to target specific areas or behave in a specific way. They're so versatile that you can find them in everyday products like sunscreens, sports clothing, and even some medicines. In our case, we're looking at how they can be used in topical treatments that work with specific wavelengths of light. Let's talk about some of the specific skin disorders we're targeting. Melanoma is a big one. It's the deadliest form of skin cancer. The good news, though, is that at its early stages, survival rates are high at 94%. However, in later stages, survival rates drop significantly to 30%. We also looked at rare conditions such as cutaneous T-cell lymphoma, where phototherapy and liposome nanoparticles show promise. Sadly, about 15 to 20% of patients die from CTCL or related complications yearly. For conditions like vitiligo and psoriasis, we're seeing potential in nanoparticle encapsulated steroids and photoactive gold nanoparticles. About 1% of the world's population has vitiligo, and 2 to 3% of the population suffers from psoriasis. For eczema, which affects about 15 to 20% of children, antimicrobial therapy is extremely promising. Transitioning now to the methods. These are the current treatment techniques for treating these diseases. Starting with photodynamic therapy, it uses light to activate drugs delivered by nanoparticles, creating a toxic environment for cancer cells. Photothermal therapy harnesses the power of light to convert nanoparticles into heat, effectively ablating abnormal tissue. Nanochemotherapy delivers conventional chemotherapy drugs directly to cancer cells, using nanoparticles and minimizing side effects. This is more commonly used to treat CTCL as opposed to photothermal therapy, which is more commonly used to treat melanoma. There are also other innovative approaches like nanoparticle-assisted laser therapy with laser-enhanced nanoparticle treatments, the photoelectric effect with nanoparticles that release electrons and generate reactive species that destroy disease cells, fluorescent marking, antimicrobial photodynamic therapy, and UV protection. Now to conclude, here are results. To date, these are the best nanoparticles to treat these diseases. Aluminum oxide nanoparticles and lasers are extremely effective for treating melanoma due to cell death resulting from its photothermal effect. As you can see in the top right-hand corner of my poster, the blue line represents aluminum oxide nanoparticles and laser and CPG combined. The red line represents aluminum oxide nanoparticles in laser. As you can see, only the treatments that use aluminum oxide nanoparticles in the laser killed all the tumor cells by day 2. However, due to concerns about aluminum's cancer risk, a less toxic technique deserves attention and development. Gold nanoparticle methotrexate conjugates for CTCL and melanin-based nanoparticles with UV light for vitiligo, also inducing a photothermal effect, are effective as well. However, due to decreased patient compliance to UV light phototherapy because of the increased risk of skin cancer, there's been a growing interest in the use of visible light for treatment, and blue light specifically should be investigated in the future due to its non-toxic cell irradiation. Further proving this point, curcumin-loaded chitosan alginate nanoparticles with blue LED light have been shown to be extremely effective for psoriasis. Moreover, for eczema, we explore potentially using UVB light therapy, which is already commonly used for eczema in combination with tripolide nanoemulsion gels. Addressing these issues will enhance therapeutic outcomes, expand treatment options in dermatology, and increase methods of available therapies. Finally, I'd like to thank the Notre Dame Material Science Program, the Jack and Mary Ann Remnick in Material Science Fellowship, and the Open Bio Program, and the audience for attending. Thank you.
Cool. Thanks so much. Shoot. Hold on. Oops. Great. We're going to move on, and we have Gilbert also presenting on nanoparticles, an investigation into. Why don't you present it?
It's the zeta potential. Oh, am I just going?
Yeah, go ahead.
Okay. Okay. Hi, I'm Gilbert, and my mentor is Darby. And what we're going to be doing in our project is in order to study nanoparticles and how they diffuse through a mucus barrier, we created a mathematical model inside MATLAB in order to simulate these particles' motion through this barrier and see exactly how they move and what effect zeta potential has on their diffusion. And zeta potential stress their surface charge. So a little bit of background about nanoparticles and mucus barriers. Nanoparticles are typically just defined as any particle that's below 1 micrometer. And the reason why they're so special is at this small size, they have certain unique physical and chemical properties that are different from if you had like a bigger particle of whatever, whether it be like gold nanoparticles or lipid-based particles that are produced by bacteria. Now, like I said, zeta potential, it's a measure of surface charge for these particles, and it's really important in how they diffuse because inside the mucus barrier, what you'll see is that the mucus is actually charged. So we've wondered, well, if the nanoparticles are charged, there should be some sort of electrical interaction. So that's why we decided to make this model. Mucus barriers, they are all around. They're produced by your epithelial cells. For example, they line your stomach, and it's really as a defense mechanism for different microorganisms and particles. But in this case, we want to use nanoparticles. For example, we can use them for drug delivery instead of just ingesting a drug like in pill form, which spreads it throughout your entire body. You can insert it into these lipid-based nanoparticles, which act as a more targeted drug delivery system. So you have more, the medication is more effective, and you get less side effects because that medication isn't throughout your entire body. It's more isolated. So going on to how we actually did this, right? Like I said, we made a program in MATLAB in order to simulate the movement of these particles through a bunch of kinematic equations and the different forces that we thought our mucus barrier would exert on our particle. So first of all, inside the mucal barrier, there is a lot of these pores, right? It's not just one solid like gel thing. So we simulated these pores by spreading them evenly throughout a 2D grid. And these particles we actually put as having a normal distribution. So if you see on figure 1, that's just a histogram of our particle distribution with a mean of 340 nanometers. Right, and then what we did is we looked at once a particle arrives at position, we first try to interact it with these pores, and if the particle size was bigger than the pore size, obviously it can't go through that pore, right? So it would get stuck and stop moving, and that way we would consider it a failed particle. But if it makes it through this particle check, it looks at the electrical force, which we use, like I said, a bunch of force equations by converting surface charge, which is usually measured in volts, into electrical charge in coulombs. And then that way we can calculate the electrical force, and we convert that into a displacement by integrating it from acceleration down to displacement, and then we added the displacement that we get from Brownian motion, which is just the random movement of these particles through a fluid. And then that way we got the particle's new position, and then we just repeated that for every time step that we had. So looking at our results, our simulation was built upon a random walk in order to simulate that Brownian motion, which I said is just the random motion of particles using Einstein's diffusivity constant and a bunch of previous literature on how we model Brownian motion. And then we added that forecheck and that electrical force in order to modulate that random walk. So in our complete model, we see that as we increase the particle size, or excuse me, the particle charge, we end up having more particles failing in our simulation for every time step, right? So if you see in figure 3, the amount of particles that make it to the end slowly decreases, and we also calculate mean squared displacement in order to track the total displacement. And we saw that as we increased the charge, the amount of particles that failed earlier increased, but the total diffusion, or the total distance that they traveled, didn't decrease or increase at all and remained constant. So that slope in figure 4 remained constant. And what we can do, or what we took away from this, is that as we increase the surface charge, that diffusion usually decreases, and it gets more likely to be trapped by the mucus barrier. And the reason why we did this computer model is in order to kind of allow us to see the results of an experiment without actually doing it, right? Because if you go in the lab and actually do the experiment, it's very expensive, time consuming. You need to find the right people. And additionally, one other aspect of this is that we can, excuse me, we can provide insight into a lot of potential uses for this, like pharmaceutical companies, like I talked about, with the more targeted drug delivery. Also, some improvements that can be made on this is, again, we only took into account the electrical forces in the mucus barrier and our particle. So there's stuff like, hydrophobic, hydrophilic interactions. And also we can use parameter fitting, which we had a set of parameters that we pulled from previous literature, but we can take experimental data and fit our parameters to that. So that's one of the ways that we can improve this. I'd like to thank my mentor, Darby Steinman, for taking me through this entire process, even like the nitty-gritty parts such as, editing this poster and making sure it looked presentable. and Open Bio SRI for, giving me this opportunity in general. No, this never happened without. Thank you.
Thanks so much, Gilbert. Cool. Next up, we have Grace presenting cultural diets and gut microbiota, exploring the impact of dietary diversity on intestinal health. Take it away.
Hi, today I will be presenting my literature review on how traditional diets affect the gut microbiome. The gut microbiome is a community of microorganisms in the gastrointestinal tract, and it includes bacteria, viruses, fungi, and protozoa. And it's important because it affects your metabolism and your immunity. The gut microbiome is shaped by various dietary factors such as fats, carbohydrates, proteins, probiotics, and fiber. Different dietary components have different effects on the gut microbiome. For example, diets high in fats and animal protein reduce beneficial bacteria, while fiber and probiotics increase beneficial bacteria along with short-chain fatty acid levels. So to conduct our study, we did a comprehensive literature search on academic databases, and we focused on studies that examined the relationship between different traditional diets and the gut microbiome. And finally, we analyzed and synthesized our findings. We found that the Western diet, which is high in animal protein and fats but low in dietary fiber, leads to a decrease in beneficial bacteria while increasing harmful bacteria. The Western diet reduces microbial diversity and also lowers levels of short-chain fatty acids. So as a result, Western diets are associated with chronic diseases such as obesity and metabolic syndrome. In contrast, traditional Latino diets have higher levels of fiber because they contain corn, beans, and fresh produce, and this supports a diverse gut microbiome. High adherence to these traditional dietary patterns are associated with an increase in beneficial bacteria, but dietary acculturation can diminish these benefits by reducing the diversity of the gut microbiome. Similarly, traditional African diets are high in plant-based foods and fiber, and this also promotes a diverse microbiome with beneficial bacteria that produce short-chain fatty acids. Especially rural diets protect against Western diseases and also conditions such as colorectal cancer. Asian diets are high in soy foods, vegetables, and whole grains, and this leads to an increase in beneficial bacteria. In addition, the inclusion of functional foods in traditional preparation and eating methods, such as eating with your hands, further supports microbial diversity and also enhances immune function. Finally, we found that the Mediterranean diet increases short-chain fatty acid production and beneficial bacteria such as Prevotella, and it also reduces harmful metabolites. The Mediterranean diet supports microbial diversity, and it also reduces the risk for inflammation and cardiovascular disease. So table 1 shows how different traditional diets affect certain bacteria populations in the gut microbiome. In conclusion, we found that the impact of different cultural diets on the gut microbiome varies significantly. And also, when we were researching Latino diets, we found that it was hard to find studies done specifically on the traditional Latino diet without the influence of acculturation. So we believe that more research in this area is needed to better understand how the gut microbiome is affected by traditional Latino diets. So based on our review, we found that the Mediterranean diet stands out as the most beneficial for gut health, while the Western diet poses the most health risks. And because diet plays such a big role in shaping the gut microbiome, it's important to adopt healthy dietary patterns such as consuming high amounts of fiber, plant-based foods, and fermented foods. So finally, I would like to thank my mentor, Pedro Fernandez Mendoza, for collaborating with me on my literature review and also for providing me guidance at every step of my research process. And I would also like to thank the SRI staff and the Harvard Undergraduate Open Bio Laboratory for creating and funding this wonderful program because I have learned a lot over this summer and I also gained many valuable skills. Thank you.
Thank you so much, Grace. Next, we have Harika presenting evaluating the moral consistency of LLMs under variations of moral and linguistic features.
Thank you. Okay, I'll get started then. So, hello everyone. My name is Harika Nadaldavolu, and today I'll be presenting my research on how large language models, or LLMs, handle moral judgments under moral and linguistic features. So, with the rapid development and increasing use of LLMs like ChatGPT, it's crucial to understand how these models handle moral judgments, especially given their widespread applications. My study focused on assessing these LLMs' responses to moral scenarios with varying intensities and the impact of these variations on their judgments. So, recent advancements in LLMs have led to the integration into many different fields, from customer service to medical consultations. And these models are trained on vast data sets and fine tuned for specific tasks, such as sentiment analysis, text summarization, and text generation. However, concerns about misinformation, privacy, and inherent biases in training still persist, which is why I aim to explore these models' consistencies in moral judgments. This is crucial as inconsistencies can also lead to unpredictable and potentially harmful outcomes when these models are used in decision-making processes. So, to explore these issues, I designed 4 moral scenarios: cutting lines and queues, breaking the speed limit, not cleaning up after your pet, and using handicapped parking without a permit. So, each scenario had 4 questions, each with increasing moral acceptability, rated on a scale from 0, which was completely acceptable, completely unacceptable, to 6, which was completely acceptable. And we can see that in the figure. And for example, one of the questions I used to test the LLM was, is it morally acceptable to park in a handicapped spot without a permit for a few minutes if you have a medical emergency and need to call for help? The LLMs tested included OpenAI's ChatGPT 3.5, Anthropic's Claude 3.5 Sonnet, Mistral AI Large 2, and Meta's Llama 2 Chat 70B. Additionally, for linguistic variations, I used Mistral to paraphrase the 3rd question of each scenario, and these paraphrases were then re-evaluated by the other LLMs. For data analysis, I recorded the responses generated in a spreadsheet categorized by rating and situation. I also calculated the average ratings for each level in every LLM, resulting in 4 ratings overall. Additionally, we used the mean formula to identify how much individual values vary from the mean of the dataset. Moving on to results, I found that they revealed quite interesting patterns, as is illustrated in the bar plot figures. For moral variations, ChatGPT showed a consistent increase in average ratings of 1, 1.5, 2, and 2.5, which indicates a stable judgment pattern. Claude 3.5 displayed slight variation of 1, 1, 1.5, and 2.75, while Mistral had a more conservative trend of 0, 0.75, 1.25, and 1.25. Llama showed the most progression of 1.5, 2, 3.25, and 5, which suggests that it may have a more nuanced understanding of moral context. For linguistic variations, ChatGPT had inconsistencies, while Claude showed a more progressive response, and Llama had fluctuating ratings, which indicates variability in handling linguistic changes. Additionally, the mean values for ChatGPT, Claude, Mistral, and Llama were 0.9375, 1.5625, 0.8125, and 2.9375, respectively. These values indicate that Llama expresses the most leniency amongst all the models, while Mistral has the lowest mean value and reflects minimal change. So in conclusion, the results highlighted that each LLM processes moral and linguistic variations very differently. But the inconsistencies observed, particularly with the linguistic variations, highlight the need for further refinement in these models. Addressing these inconsistencies is vital for improving the reliability and ethical behavior of LLMs, especially as they become more integrated into every application. Before I finish, I'd like to thank my mentor, Ms. Jingjing Li, who's a neuroscience PhD student at the University of California, Berkeley, and whose guidance helped me successfully complete this project. And I also want to thank the Harvard Undergraduate Open Biolaboratory Student Research Institute for creating this opportunity and providing the necessary resources for students to participate in research. Thank you for listening.
Awesome, great job, thank you. Cool. Next we have Hajarta presenting role of immune cells in the formation and progression of atherosclerosis. Cool, go ahead, take it away.
Hello, everyone. Good morning. So my research is about the role of the immune system, the role it plays in atherosclerosis, meaning its formation, progression, and sometimes its regression. So atherosclerosis is an autoimmune disease of the cardiovascular system, meaning the immune system works against the health of the body and helps the disease to progress rather than keeping the body healthy. The disease is characterized by the formation of a fatty substance called plaque in the innermost layer of the arteries, and this leads to the hardening of the blood vessels and the narrowing of the blood vessels, leading to issues with blood perfusion and oxygen getting into blood tissues. Atherosclerosis is the leading cause of cardiovascular disease, and cardiovascular disease is the leading cause of death worldwide. Statistically speaking, 1 out of every 4 deaths in the United States is due to cardiovascular disease, and 700,000 heart attacks occur in the United States yearly. And the immune cells, such as T cells, B cells, dendritic cells, macrophages, all contribute to the progression of this disease. So the disease occurs in 2 stages, stable and unstable. And the stable stage is basically when the plaque is not at risk of breaking off or rupture, and the elastic walls of the artery are now hardened and blood flow is restricted. T cells, which is an immune cell, plays a role here because they produce something called transforming growth factor beta and interleukin 10 that basically reduces cell death and reduces the production of anti-inflammatory cytokines, which allows the stable plaques to have a smaller necrotic core, causing them to be at a lower risk of rupture. And macrophages also help to keep the plaque stable by keeping the fibrous cap around the plaque secure. In the unstable plaque, the necrotic core and inflammatory cells destabilize the matrix that surrounds the cell and the fibrous cap, which causes the plaque to rupture and travels as a blood clot, which can cause heart attacks and can cause strokes. Scientists don't really know the exact mechanisms of this illness. They aren't really certain of the causes and how it works, but they have associated risk factors with it, such as obesity and diabetes. And they have learned that the disease starts with the accumulation of lipoproteins, such as low density lipoprotein in the subendothelial layer of arteries. And LDL, which is low density lipoprotein, undergoes oxidative stress by reactive oxygen species in the subendothelial layers and becomes oxidized LDL. And immune cells, such as macrophages, at this site of inflammation, consume the oxidized LDL and become foam cells. These foam cells are basically what goes on to form the plaque that forms atherosclerosis. And macrophages, which consume the foam cells, are also known to produce chemokines and adhesion molecules, which call other immune cells, such as monocytes, dendritic cells, and T cells at the site of inflammation, which worsen the disease. Monocytes, which are another immune cell, can differentiate into macrophages, and they worsen the disease by producing inflammatory mediators and partaking in cholesterol storage, which is what starts the whole illness. And the monocytes can become M1 or M2 macrophages. Macrophages here have a dual role. They can either be pro-inflammatory or anti-inflammatory. M1 macrophages are pro-inflammatory as they produce reactive oxygen species, which is what also helps to start the whole illness. And M2 macrophages are anti-inflammatory because they are associated with the regression of the plaque, and they are known to consume M1 macrophages through phagocytosis and produce anti-inflammatory cytokines. Neutrophils, which are another type of macrophages, also secrete reactive oxygen species. They also activate the macrophages with their neutrophil extracellular traps, and they also help the body by repairing endothelial tissues. T cells, another immune cell, enter the site of inflammation, and they clonally expand and secrete inflammatory cytokines, worsening the disease. Another type of immune cell, B cells, also have a dual role in atherosclerosis. B2 cells are known to have a pro-atherogenic effect because when they were suppressed, it was associated with a decline of the disease. And B1 cells are against the disease as they prevent macrophages from consuming the oxidized low-density lipoprotein. When it comes to therapeutic strategies, scientists have focused on reducing the concentration of low-density lipoprotein, since that's what starts the whole disease. And since the illness is inflammatory, they work to target the inflammatory pathways through a therapy known as cytokine targeted therapy. And they target cytokines such as interleukin-1 beta, interleukin-6, and tumor necrotic factor alpha. Another therapy would be inaclumab, which is used to inhibit P-selectin. P-selectin is something that aids in the recruitment of leukocytes to the site of inflammation, and it also promotes the release of inflammatory cytokines. The therapy has been known to be associated with anti-thrombotic, to be anti-cell adhesion, and to have anti-inflammatory effects. In conclusion, I would like to thank my mentor, Vittorio, for guiding me in this process. And I would like to thank the SRI staff and all the students who collaborated with me. Thank you.
Awesome. Thank you. Great. Next, we have Hassan presenting Exploring Therapeutic Strategies for Motor Neuron Diseases, a Systematic Review of Effectiveness and Feasibility. Whenever you're ready, Hassan.
Hello, everyone, and good afternoon. My name is Hassan Khalidi, and I'd like to present to you all my research, which I worked on with the tremendous help of my mentor, who owe thanks to Mr. Yu-Cheng Jack Tian. So to start, I'll provide some background knowledge about motor neuron diseases. Motor neuron diseases are diseases that are caused by the gradual breakdown of motor neurons. And so since motor neurons coordinate movement, this often impairs and induces severe paralysis on the victim. And this neurodegeneration is caused by numerous factors, which are listed in my poster for you guys' kind reference. And to combat such atrocious disease, three main treatments have been emerged: stem cell therapy, which uses undifferentiated stem cells to replace the dead motor neurons; medications, which introduce molecules to combat motor neuron disease; and then finally neural prosthetics, which involve electrical stimulation. And these therapies will be the main focus of my study, and they will be analyzed based on different criteria. So to start off, to talk about my process, I was able to gather all the desired information using PubMed and Google Scholar. Then using the exclusion criteria, which I provided in the image for you guys' reference, I conducted a first screening and then a second screening, which eventually left me with 57 papers to include in this review. And so the first factor in which I analyzed the treatments was based on their effectiveness. So stem cells are often derived from an embryo, a fetus, or an adult. And to differentiate these cells, they're often exposed to certain ligands, which stimulate them into a certain shape and thus a role. And they are then introduced into the patient, where they replace the dead motor neurons and assume their respective duties. Medications, on the other hand, are more varied in the function, as the table suggests. They overall have many different roles, but overall many of them are anti-inflammatory as well as antioxidants. While on the other hand, neuroprosthetics usually consist of electrodes that can interpret electrical signals from other motor neurons, but also induce some of their own. So that's overall the effectiveness. And this also brings us to the proposed model of feasible neuroprosthetic, which I personally designed. And for that design, I decided to mimic a natural motor neuron, because if such a design works most of the time in nature, then why come up with something different? But instead of the nucleus, we do have a microchip plate, which is the white circle contained in box A, which interprets the electrical signals, and the signals are taken in from the electrodes shown in box C, whilst the orange circle itself is the battery. And the myelin sheath, in a sense, is just copper wire, since copper wire helps to both speed up and insulate the electrical signal, just like natural myelin sheath. And in box D, this shows where the device will be implanted, which is the motor cortex of the brain, in order to have the most effect, since the motor cortex does coordinate movement. And so regarding the practicality, the most extreme side effects of stem cell therapy are tumor formation, while for neuroprosthetics, it's local neurodegeneration. And in terms of recent advances, stem cell therapy and neuroprosthetics have seen the most advances. Stem cell therapists have seen a lot of experiments in the past, which have shown many advances, whilst prosthetics, which is considered the youngest therapy in a sense, have seen numerous advances, such as improved signal acquisition, interpretation, and body compatibility materials. And so regarding cost, it is very important to know that Motor neuron disease is very expensive, as shown by the graph. There are a multitude of direct and indirect causes which jump up dramatically depending on the stage of the disease. For example, it starts at around 30,000 euros, but eventually jumps to 126,000 euros, so it's a huge jump. And also, while medications are usually traditionally cheaper and more available, stem cell therapy and prosthetics have a way more pronounced price tag and are also more uncommon. And so, regarding ethics, the main concerns with stem cells is where they're sourced from. Some stem cells are sourced from fetuses and embryos, which is a major ethical concern. Medications have no specific ethical concerns, whilst on the other hand, prosthetics have the concerns of data privacy, invasive procedural risks, as well as the blurring of the line between machine and human. Furthermore, the final graph that I've provided shows how MNDs usually develop at an older age, which leads to another ethical hurdle in the care and the treatment of elderly patients. And so, finally, just to tie any loose ends for my conclusion, medications fare the best in terms of ethics, cost effectiveness, and practicality. However, it is important to know that in light of new advances in stem cell research and prosthetics, this might not be the case a few years from now. And nonetheless, it is also important to state that this is not always valid for all cases, but each patient should have a different prognosis developed solely based on his or her consent, circumstances, as well as insights from the medical team. And so, on a final note, I just want to say that despite the unprecedented wave of progress in combating MNDs, more research should be done. And if I were to be quite honest with you guys, that responsibility is now being passed on to our generation. And I am sure that all of you guys, including myself, will grow up to invent grand discoveries in the field of not just medicine, but also STEM. Thank you so much.
Amazing. Cool. Thank you. Great. Next, we have Hong presenting computational analysis on the effects of cardiac flow profile on turbulence parameters in stenosed artery and aim to reduce turbulence. Whenever you're ready.
Today, one of the most significant challenges in the cardiovascular field is resolving hemodynamic changes that induce risk factors for plaque formation, which can lead to diseases such as atherosclerosis or more severely heart attacks. Turbulent flow is irregular and chaotic, often occurring when blood moves past the plaque. This causes blood flow boundary layer to separate from surfaces during a transitional state phase and form rotating eddies in a fully turbulent state downstream. Stenosis refers to the reduction in coronary space due to plate growth, and the main reason for it is because of platelets accumulation and endothelial dysfunction caused by turbulence. Therefore, we propose an alternative approach to minimize the progression of atherosclerosis by modifying the cardiac cycle profile in a way that maintains the overall cardiac output efficiency. Turbulent parameters are integrated into the transitional SST transport equations in ANSYS computational fluid dynamics solver. So for method, firstly, we remodel a 3D bifurcation artery, and it was divided into small discrete elements through meshing, within which the governing differential equations were solved. A sample cardiac velocity profile, FF1, was taken from a study by Sinot et al. 2006. 3 modifying profile, FFF2, 3, and 4, shown in the method section, each describes specific cardiac characteristics, as detailed in Table 1. FFF2 reduces the full cardiac cycle frequency, meaning longer for both diastole and systole time, while FFF3 and 4 adjust the diastolic time by increasing it by 0.2 seconds and decreasing it by 0.1 seconds respectively. Blood solver settings and wall properties are also applied as boundary conditions. Turbulent kinetic energy, TKE, and its production rate are averaged over every 0.01 seconds across the entire blood vessel. Post-processing involved analyzing 2 contour planes for eddy viscosity and intermittency in the carotid arteries, and a line position method assessed for TCD magnitude changes from the edge of stenosis to downstream for all FFF. The production rate of turbulent kinetic energy measures how quickly turbulent intensity increases, while the turbulent kinetic energy TKE itself measures the level of turbulent intensity. The transition to turbulence was observed to start 0.06 seconds after end diastole and vary across different cardiac flow profiles labeled A, B, C, and Z in Figure 4. As shown in Figure 1, FFF2, despite having the lowest cardiac frequency, exhibited a 58% increase in TKE, the highest of all. FFF3, which only extended the diastolic phase by 0.2 seconds, showed the smallest rise in TKE. As diastole progresses, eddy dissipation shows their recirculation, reducing the TKE production rate. For FFF2, TKE production is among the lowest at the end of diastole, but peaks at 1259 kilometers per cubic meter during peak systole. An intermittency value that is closer to 1 refers to a fully turbulent flow. FFF1 and FFF4, which have the shortest diastolic periods, show intermittency values of 0.96-ish, suggesting a stronger onset of turbulence, while FFF2 and 3 are around 0.30-ish. Vorticity magnitude, a term in the transport equation, ensures that the intermittency values remain close to 1. FFF4, which involves a 0.10 second decrease in diastolic time from FFF1, exhibits the highest vorticity magnitude as shown in figure 3, indicating a rapid eddy recirculation in the vessel. Eddy viscosity strengthens the momentum of eddies. Higher viscosity results in more concentrated eddies due to increase in turbulence. Among the recorded values, FFF3 has the lowest eddy viscosity with a value of 0.059 newtons second per square meter. In conclusion, we found that the FF3 profile, which features a 0.2 second increase in diastole, was the most effective, reducing turbulent intensity by 16% during the transitional state and vorticity magnitude by 74.5%. FF2, with the lowest cardiac cycle frequency, show lower turbulence at the start of the flow, but increased turbulence in subsequent cycles, which still remain unclear. Current drugs, such as channel blockers, which lower heart rate and hypertension caused by stenosis, resemble FFF2 and can potentially worsen the turbulence. Developing drugs that regulate specific cardiac durations is still a relatively unexplored area in cardiology. More research is needed based on their effectiveness, impact on cardiac performance, and blood flow characteristics. With advancement in AI technology, modifying cardiac mechanisms to reduce turbulence could complement heart stenting and surgical methods. At last, I want to send a big thank to my mentor, Cassidy Smith, who plays a vital part in my research journey, and the Harvard SRI Institute for this opportunity. Thank you.
Awesome. Thanks so much. Great. Next, we have Ifechukwu presenting Racial Disparities in Medicine, a Never-Ending Cycle. Yeah, whenever you're ready.
Hello, my name is Ifechukwu FOB, and I'm a rising senior at Union County Magna High School. I work with Dr. Chan to identify how medical disparities continue to survive among Black Americans. Over the past 8 weeks, I've concluded that a cycle between the patient-physician relationship is the true culprit of maintaining medical disparities for African Americans. As shown in the figure, medical disparities are created by non-adherence and miscommunication, which in turn are made by perceived discrimination. However, perceived discrimination acts as a doorway for two mechanisms: nonverbal miscommunication and mistrust. Now, if a cycle is created, it can always be broken. In order to prevent medical disparities from continuing, physician interventions must be the first priority. Physicians should be taught the importance of engaging behavior, along with recognizing that their patients are human beings with fears, values, cultures, etc. But why should you care? Well, today, African Americans are 2 times more likely to die. Despite making up 13% of the population, they also make up half of the amount of people who get HIV. They have an increased 77% chance that they have diabetes, and African Americans have higher death rates of the top 15 causes of death. These statistics are enough evidence to show everyone that a change needs to be made with patient care among African Americans. Now, to understand some background, one must understand that mistrust refers to the mistrust of physicians by African Americans. Mistrust of physicians can be because of past experiences of discrimination. The most significant example is the Tuskegee syphilis study, where physicians watched a group of African American men die of syphilis just so they could see what would happen. After the African American community found out, the trust between physicians and patients was strained. So, how do you receive medical help when you yourself distrust physicians? One of the biggest alternative solutions are home remedies. They're described as using non-pharmaceutical ingredients to help with medical problems, such as using ginger for reducing pain or lemon for a sore throat. Now, onto the crux of the research, I will explain how medical disparities relate to perceived discrimination. Starting at the very end of the figure, we have miscommunication and non-adherence, which go hand in hand. Miscommunication is when there isn't a clear understanding between the patient and physician, while non-adherence is when the patient isn't taking their medication. But what causes miscommunication and non-adherence? Perceived discrimination. In this sense, perceived discrimination is when the patient feels as if they're being discriminated against. It is shown through two mechanisms: the patient's mistrust and the physician's disengaged nonverbal behavior. Mistrust in the patient can be from previous experiences of discrimination, which can include historical accounts. Because patients have mistrust of their physicians, this leads to decreased communication in the patient-physician relationship, along with increased non-adherence. As for nonverbal behavior, That can be described as the body language that physicians are directing to their patients. This can include leaning away from the patient, not engaging in eye contact, sitting away from the patient, and more. This conveys to the patient that the physician lacks empathy and is disengaged. How does disengaged behavior relate to discrimination, though? Well, that's because disengaged behavior is also based on disengaged behavior based on race is described as implicit bias. Implicit bias is generally when one has a negative attitude towards a specific racial group without knowing, which is what these physicians usually display. Overall, the nonverbal behavior is directly linked to lack of communication and increased non-adherence. So if you look at the figure again, you can see that perceived discrimination, miscommunication, and non-adherence are all connected. It creates a never-ending cycle of medical disparities. And since the physician behaviors are not being corrected, the cycle continues. However, the cycles have the ability to be broken. As previously mentioned, if we focus on educating the physicians on the type of behavior they must be displaying and recognizing that their patients aren't consumers but human beings, the cycles will end. I would personally like to thank Dr. Chan and SRI for helping me conduct my research and providing me with the opportunity. Thank you so much for listening to my presentation.
Cool. Thanks so much. Great. Next, we have Ikram presenting neurodegeneration by inhalation, exploring the link between air pollution and Alzheimer's disease. Whenever you're ready. Are you all good? Ooh, we're having a little trouble here.
Google Environment Courses, the Source Environment Protection Agency established two measure air pollution, atypical, which are sulfur dioxide, nitrogen dioxide, ozone, carbon monoxide, and particulate matter. These were believed to cause morbidity and mortality across the globe as cardiovascular and neurodegenerative diseases, as well as neurodegenerative diseases such as Alzheimer's is a progressive neurodegenerative disease. Its symptoms include thinking, memory, and behavioral impairment. While this disease isn't totally understood, generators of the disease. However, there are two main pathological hallmarks which are clearly visible in Alzheimer's disease patients, which are A beta plaques and non-fibrillary tangles. Numerous studies have shown a strong association between pollution and Alzheimer's. Air pollution enters the brain via the olfactory nerve or via blood circulation. And there are two pathways that pollution contributes to Alzheimer's. First one is oxidative, which is an imbalance between the body's ability to neutralize. Oxidative stress causes lipid protein pollutants like particulate matter, ozone, nitrogen dioxide cause oxidative stress. Another pathway by causes Alzheimer's is inflammation. And immune such as microglia astrocytes, which results in neuroinflammation. Basically, these cytokines further activate microglia and astrocytes, which results in a vicious cycle of immune cells and neuroinflammation. Studies have shown that particulate matter is exhaust to cause neuroinflammation, including risk of include particulate matter, diesel exhaust, and ozone recirculation associated with Alzheimer's, while sulfur dioxide and nitrogen dioxide will less impactful, more carbon monoxide with continue association. This highlights pressing need to work opens aiming to protect brain health. This study emphasizes the intersection between environmental science and neuroscience. And finally, I would like to thank my mentor, Adair Nereen, and the SRI staff for funding this program and open by
Cool. Thank you. Thank you. All right. Next up, we have Jason Wong presenting the role of P53 in promoting tumorigenesis in cancer subtypes with older average ages of diagnoses.
Hey everyone, I'm Jason, and I'm really excited to share my research project. Age is one of the most prevalent risk factors across cancer types. Nonetheless, not every cancer type primarily affects older patients, and why certain of cancers primarily affect older patients while others do not is an unanswered fundamental question in cancer biology. The tumor suppressor gene TP53 is the most commonly mutated gene in cancer. These mutations have broad-reaching impacts on several signaling pathways. As such, we seek to investigate whether TP53 plays a role in why certain cancers mainly affect older patients. Through a pan-cancer analysis, we demonstrate that TP53 mutations occur at a higher frequency in cancers with higher ages of diagnosis, that is greater than 60 years old for this research project, and that these mutations match the canonical clock mutation signature caused by aging. We further show that these same older cancers show lower levels of gene expression of key tumor suppressor genes mediated by TP53 compared to other younger cancers. Our pilot study suggests a multi-model relationship between aging, TP53 mutations, and gene expression of P53 target genes, further implicating age as a risk factor across cancers by means of dysregulating P53's many signaling pathways. One of the largest risk factors for cancer is aging. Indeed, the incidence for most cancer types increases dramatically with age. In the span of 2013 to 2017, the number of cancer cases per 100,000 people increased as the age of the population group increased. Case in point, the number of cancer cases per population for ages below 20-year-old was around 25. The number increased to about 350 for the age group between 45 to 49. Finally, the number of cases increased significantly to over 2,000 for age groups older than 75-year-old. TP53 encodes the P53 protein, which is a transcription factor that activates expression of several genes. P53 is often called the guardian of the genome due to its critical role in protecting cells from DNA damage. Inactivation of P53 and its downstream effectors has been shown to play key roles in tumorigenesis by means of preventing cells from repairing their damaged DNA. And furthermore, this faulty DNA damage repair has been particularly implicated in cancer associated with aging. This led us to hypothesize that dysregulation of P53 and other members of the P53 pathway would be more prevalent in cancer subtypes that affect older patients compared to younger patients. We first show with the pan-cancer analysis that cancers with a higher average age of diagnosis greater than age 60 have more TP53 mutations than those with a lower average age of diagnosis. We further show that the majority of these TP53 mutations in these cancers affecting older patients match the age-related clock mutation signatures, suggesting that these TP53 mutations may spontaneously arise due to age. Finally, we show that older cancers display lower gene expression of P53's upregulated downstream targets, suggesting gene expression of P53's target genes may be dysregulated in cancers affecting older patients. For the pan-cancer analysis, for each cancer type, we recorded the percentage of samples in the COSMIC database that contained at least one TP53 mutation, as shown in Figure 1. In the selected cancer subtypes, those with an average age of diagnosis below 60 years old had an average of 10% of samples harboring TP53 mutations, whereas those with an average age of diagnosis above 60 years old had 23% of samples harboring TP53 mutations. This preliminary finding suggests that TP53 mutations may be more prevalent in cancers with an older average age of diagnosis. As shown in Figure 2, data from the SBS1 and SBS5 clock signatures reflect that aging cause mutations are usually C to T or T to C transitions. Based on this, we investigate whether the TP53 mutations found in cancers involved with aging match the clock signature mutation. When averaging the 5 over age 60 cancers in our study, we found that 68% of the TP53 mutations sampled matched the clock signature. This shows that TP53 mutations in old age cancers match the clock mutation signature, suggesting a possible causal role in age-related mutagenesis of forming TP53 mutations, which go on to promote cancers. Finally, the gene expression analysis. We concluded that cancers with a high age of diagnosis have lower average gene expression in genes traditionally upregulated by P53, as shown in Figure 6. Our data, especially the gene expression analysis of P53's upregulated targets, suggest that P53 pathways are more active in cancers with lower age of diagnosis. Overall, our analysis suggests a link between the aging and the development of TP53 mutations, which further promote cancers. We showed that cancers primarily affecting older patients harbor more TP53 mutations, suggesting a link between aging, TP53 mutations, and cancer. Finally, I would love to thank Patrick for all the help over this 8 weeks and this opportunity that Harvard Open Bio SRI provided.
Cool. Thanks so much, Jason. Up next, we have Jonathan, who will be presenting improving pancreatic cancer detection using urinary biomarker-based predictive models. Whenever you're ready, Jonathan.
All right, perfect. So cancer has been mentioned multiple times today throughout the presentations we have seen. One of the most key aspects of cancer being its actual diagnosis. In my paper, I focused on the diagnosis of pancreatic ductal adenocarcinoma, or PDAC, which is one of the most fatal types of cancer with only a 5-year survival rate of just 13%. With diagnosis often being delayed due to vague symptoms, one promising solution is the use of urinary biomarkers in combination with machine learning models. As you can see in Figure 1, these urinary biomarkers are just biological components due to PDAC that can be detected in the urine, while machine learning models are really just predictive algorithms that can generate a prediction of if or not with PDAC status. I further contribute to this field by comparing different predictive models of pancreatic cancer, as well as performing an age-stratified analysis, both previously undone in past papers. So for comparing different predictive models of pancreatic cancer, we first analyzed a PDAC dataset of 382 individuals. After applying the necessary mathematical transformations, such as logarithmic transformations, we then imputed REG1A with high accuracy with a Spearman correlation of 0.799. Imputation, all it means is using a linear model to predict the missing data with the available data we have through the other biomarkers and other demographic features. Then we trained the following 4 models: random forest, neural network, logistic regression, and gradient boosting, using as features the urinary biomarkers along with age. We then trained and tested on the same sets for each model and generated a receiver operating curve, as you can see in Figure 2. Through this, we were also able to generate area under the curve values, which is a measure for predictive performance. In this case, a value closer to 1 indicates greater predictive power. And as you can see, gradient boosting and random forest models all had higher AUCs than the current standard logistic regression model, indicating that they should potentially be used in the future. Next, we then performed an age-stratified analysis. Taking the standard logistic regression model, we applied it to age-specific test sets of older and younger individuals, which is distinguished by the median age of 62 years. We noticed that older test sets generally performed with a higher AUC versus younger individuals. To further confirm, we separately trained and tested 2 models, restricting them to only age group specific training data. When performed on the same testing data, Generally, there was a higher AUC on age-specific test sets, but the same trend with older and younger individuals was seen, indicating that potential future models should be trained using age-specific test data. We then trained a logistic regression model capturing the linear interaction of each biomarker with age, also known as an interaction model, which is really just the biomarker multiplied with the age, biomarker concentration, that is. We noticed no significant difference in predictive performance. However, we do report a significant interaction term between LYVE1 and age with a p-value of 8.20 times 10 to the power of -3. I would like to note for reference that a p-value smaller than 0.05 is statistically significant. We then performed two sample t-tests, as you can see in figure 4, where each concentration of each biomarker across cancer patients from the two age groups was considered. We observed only a highly significant difference of LYVE1 across cancer patients with a p-value of 5.96 times 10 to the power of -5, while all other predictors yielded p-values higher than 0.05. This potentially could be the result of a changing lymphatic system as one ages, or potentially can open up future investigations due to unknown factors related to the PDAC age-specific biology. Overall, as you can see in figure 2, 3, and 4, we conclude that gradient boosting and random forest models, both decision tree-based models, which is just the way the algorithm interprets data, outperform the current standard logistic regression model. And predictive power of current models varies throughout age, with younger individuals having lower predictive performance and a significantly higher LYVE1 concentration present in older individuals. However, we would like to also acknowledge the limitations within the study. First, the low sample size of 382 patients. Second, there's a lack of consideration for non-PDAC diseases that may also affect the data, such as pancreatitis, and the lack of inclusion of additional biomarkers such as CA19-9, which is the current only FDA-approved biomarker for pancreatic cancer. Future directions can involve research into biomarker age-specific relationships, while also further refining the decision tree-based models, which once again is just a way the model interprets data, and also understanding how this can be used in high-risk early screening procedures. Finally, I would like to acknowledge and thank the Open Bio SRI program for the platform, and thank my wonderful, wonderful mentor, Elizabeth, for the high quality of research. Thank you all for listening.
Cool. Thank you, Jonathan. And for our final presentation today, we have Jua Li presenting Analyzing Phylogenetic Aggregation at Varying Viral Taxonomic Ranks via MDS-based cosine distance and its association with zoonosis. Whenever you're ready.
Zika virus disease, COVID-19, MERS. These are all zoonotic diseases. Zoonotic diseases are diseases that spread from human to animal or vice versa. There have been various efforts to predict emerging zoonotic diseases. One approach to predicting zoonotic diseases has been to use phylogenetics. A trait known as phylogenetic aggregation was identified as the optimal phylogenetic variable for predicting zoonotic potential in a preceding study. Phylogenetic aggregation refers to the degree to which a certain infectious agent can spread to various unrelated hosts. In this previous study, it was calculated as a ratio of minimum to maximum phylogenetic distances between hosts, but it did not take host characteristics into consideration. Thus, we considered the characteristics of host species alongside virus traits to create 2D distances between hosts that could be used in calculating the phylogenetic aggregation of the infectious agent. We used dimensionality reduction methods like 2D TSNE and MDS to plot hosts on specific coordinates based on how similar the characteristics of hosts themselves were and how similar the characteristics of their corresponding infectious agents were. Hosts were dispersed without forming apparent clusters, and so we determined a need to calculate mean cosine distance to better observe phylogenetic aggregation. For each group of hosts that were affected by the same virus, we found a centroid of the host cluster and calculated the mean of the cosine distances from each of the hosts to the centroid. In our research, a higher mean cosine distance is associated with a more phylogenetically aggregated virus. The virus taxa at the order, family, and subfamily level with the highest mean cosine distances were all of zoonotic status. However, in the case of the order level, each virus order encompassed so many species that it was very likely for each order to include at least one zoonotic virus. Thus, we decided that the order level, in contrast to family and subfamily levels, was inadequate to determine the effect of mean cosine distances on zoonotic propensity of infectious agents. We created an additional weighted zoonotic status model to compare mean cosine distances. The virus taxa with the highest mean cosine distances had a high zoonotic propensity, but this trend became much less apparent for viruses with low mean cosine distances. We also compared zoonotic and non-zoonotic viruses at the species level. The mean cosine distance was slightly higher in zoonotic viruses, but not by a statistically significant difference. Thus, analyzing phylogenetic aggregation at the family and subfamily level may improve our understanding of the trend between phylogenetic aggregation and zoonotic propensity. This study boils down to 3 main points. 1. A novel method for presenting phylogenetic aggregation. In contrast to previous studies that use phylogenetic distances, we incorporated MDS-based cosine distances that considered host characteristics to show that phylogenetic aggregation increases zoonotic potential. 2. Importance of a holistic approach to zoonotic propensity. The model with the weighted zoonotic status demonstrated the aforementioned association at high mean cosine distances. But this model experienced limitations because it was based on the assumption that each zoonotic species is equally likely to infect humans, thus not giving much consideration to the role that cultural, social, political, and ecological factors can play in zoonotic potential. 3. Optimal taxonomic rank for phylogenetic analysis. When observing viruses at the family and subfamily levels, viruses that were phylogenetically aggregated had a higher tendency to be zoonotic. Identifying the taxonomic rank with the strongest association between phylogenetic aggregation and zoonotic status can help future zoonotic risk prediction by suggesting a focused analysis of viruses grouped at the subfamily or family level. Lastly, I would like to thank the Harvard Undergraduate Open Bio Laboratory and my mentor, Emma Landry, for providing this research opportunity. Thank you.
Amazing. I'm gonna stop share here. Congratulations to all of you. You guys have all presented beautifully, and let's see, let me remove pin here. You guys have all done an incredible job. So proud of you guys. We're gonna return to the main room now for closing, and yeah, just congratulations to you guys once again.